Later we'll look at the requirements, the designs and the tests, but let's start with how we plan, manage and track the work. We're now in IBM Engineering Workflow Management, or EWM for short. And this is where we manage the work, the plans, the tasks, defects, project change requests, and so on. As I mentioned in the introduction video, the aviary system has been built using SAFe, or Scaled Agile Framework. And so we actually have multiple workflow management projects at different levels. This one is at the large solution level, and we're looking at our solution team's dashboard. Dashboarding is a common capability across the platform. Dashboards can be created for the project or for teams, or personal dashboards can be created for individual users. Dashboards give instant access to the project data that's most relevant to you. Whether you're a test engineer looking at a current defect list, or maybe a project manager looking at the current status of the project. On this dashboard, you can see there are various widgets showing planning information for the solution level. Here at the bottom left, we have a list of the solution epics and the capabilities. But there is also actual work being done, requirements being written, systems engineering models being designed, and so on. And those tasks are shown here in graphs, by priority, by program increment, by owner, and by status. Let's drill down into Program Increment 1 and take a deeper look. Here we can see the solution roadmap. In our aviary project, we have two high-level solution epics, basic surveillance and automated surveillance. This view shows the breakdown of those solution epics into capabilities. If we expand this capability, manually directed flight, we can see a roll-up of how the features, such as basic flight and power management, from the program-level workflow management project contribute to these capabilities, and even how those features are further broken down into stories at the team level. In this large solution project, we're not only managing these high-level epics and capabilities, but we're also performing systems engineering work. For example, we develop a systems engineering model for the aviary epics using the Harmony workflow, from which the capabilities are derived. And these tasks allow us to plan and track that work. If we open this System Requirements Definition and Analysis task and look at the Links tab, we can see other artifacts across the lifecycle that are connected to it. If I hover my mouse over this linked requirement, we can see another common capability, Rich Hover. Whenever we have a link to another engineering artifact, we can see key information about it right here. We don't need to open the tool that the artifact resides in, and we don't need to work out where that artifact is. Now that might be a requirements engineer looking at a linked design, or a test engineer looking at a requirement they're testing against. It's a huge time saver. Of course, this is also a hyperlink, so I could click it to navigate to that linked requirement directly. But let's instead go back to our plan. There are other ways to view and work with these artifacts. For example, this solution Kanban board shows the capabilities and their current status, visualizing the flow and allowing the team to minimize bottlenecks. We can change the status of a capability simply by dragging it between columns. EWM can also impose tight process control. For example, in SAFe, the work in progress limit restricts the maximum amount of work items in the different stages of the workflow. If I try to drag another capability into the analysis column, EWM won't allow it. The work in progress limit has been reached. This allows teams to complete single work items faster by helping them focus only on current tasks, and gives them the opportunity of locating bottlenecks in their working processes before they become blockers. This WSJF view, or weighted shortest job first, allows the team to focus and select the most vital tasks to implement, those that produce the most return for the business. WSJF takes factors such as business value, time criticality, risk reduction, and so on, and combines them using an algorithm that gives us a clear view of which tasks to prioritize. For example, in our aviary project, manually directed flight is the most important, and the capability to secure the communications is less important than the capability to manage faults. Later, we'll look at the program and team management planning, but for now, we'll move on to requirements management.